Hi, and welcome to Car Corner. My name is Richard Saxton. I'm the coordinator of the automotive programs at the Community College of Philadelphia. In today's episode, Dan Reed will straighten you out on his discussion about wheel alignment. If you have any questions about the automotive program at the college, please check us out on the web. Thanks, and have a great day.
Hi, I'm Dan Reed with the Community College of Philadelphia's Automotive Technology program. Welcome to Car Corner. Today, we're going to be looking at the world of alignments. Now, alignments are something that people really don't understand why they need to have one done. They just know that at some point in owning a vehicle, it's something that gets done. And they really don't understand how it gets done either. And today, hopefully, I'll be able to explain both of those things. First and foremost, as a vehicle is driven, there's stresses and forces put on the suspension. As time progresses, you hit some potholes, you make a sharp turn, you change the tires, you change the wheels, you change a couple suspension components as the vehicle ages. Those components are going to be disturbed from their original manufactured position when the car was assembled at the factory. After we disturb those components, we're going to have to go through and readjust those components so that way they're lined back up to their original factory positions. Now, most people will get an alignment generally when they are buying tires, and that's when it's generally suggested, and that's because the biggest difference that you're going to notice with an alignment is that your tires are going to wear strangely. Now, in a short bit, I'm going to show how those angles actually cause the tires to wear. But first, when we're looking at doing an alignment, it is very, very important to make sure that all of the steering and suspension components are in perfect condition. There is no point in spending any money or any time whatsoever in aligning a car if you have worn steering and suspension components. This component right here is a tie rod. This is one of the adjustment points we have on the vehicle to adjust essentially what's known as toe, or how the steering wheel is pointed down the road. Now this one right here really has a whole lot of free play in it. And at that point, that free play, no matter how well I do my alignment, that free play, that looseness in that tie rod end is still going to be there. At that point, I can get the car aligned perfectly. And then as soon as I go down the road, that joint is going to shift and the car's alignment at that point will be thrown off. I often equate it to being a pitcher in a major league baseball. If the pitcher has a shoulder injury or needs to have an operation done on their shoulder so that way they can pitch better, there's no point in sending them to spring training with that damaged arm. You have to fix the damage first and then do the training, and alignments work the same way. When we look at other components like a control arm, we may have a ball joint or suspension bushings on the control arm. If they are worn or damaged, they have to be replaced as well. Also, ball joints come into play with our steering and suspension components. If they are worn or damaged, they also have to be replaced. And then finally, we come down to items like shocks and struts. Now, shocks and struts, depending on the specific vehicle you're working on, some vehicles require an alignment after installing shocks and struts. Other vehicles don't. Every vehicle is different, and it's going to come down to the manufacturer and what they recommend be done in terms of disturbing these components while we change them. Shocks and struts are going to really dictate the ride of the car and the handling. The springs are what's going to actually change what's known as the ride height. Now, ride height is a measurement that has to be done before we do an alignment, and it's a check to make sure that these springs over time have not sagged. Generally speaking, most cars are going to need an alignment, again, after we replace one of these components, or some shops will recommend maybe every 30,000 miles that they get an alignment done, just to make sure that there hasn't been too much change in these components. An alignment after these components have been replaced, is going to put all the components back into their factory specification, make sure the car goes straight down the road, and more importantly, if you just bought new tires, which can be extremely expensive, we're going to make sure that you get the most life out of those tires as possible by making sure that they have good, equal wear patterns and we don't wear them out prematurely. So, when we have to do an alignment, one of the things that we're going to have to do is we're going to have to make sure that we check and set our tire pressure. Tires are a big thing with alignments. They're where the rubber meets the road, and if there's going to be any apparent wear or damage to the tires because the alignment is out, the first thing you're going to have to check is to make sure that the tire pressures are set correctly. If your tires are worn, if the tires are damaged in any way, it is not worth your time getting an alignment. You're going to want to do that after you have the new tires on the car. Most tire shops will recommend getting alignment after you get a new set of tires put on the vehicle, so that way you make sure that you, again, get the most life out of your tires. Before we do the alignment though, we do have to check and set our tire pressure. It's important also to remember that you should have 2 of the same tires on each axle of the vehicle as well. You don't want to align a car with 4 different or mismatched sized tires. That won't work. Simple tape measure is what we're going to use to inspect and check our ride height. And some of the components that may have to be an added cost when you work on a car that needs an alignment are what's known as shims and adapters. Now some of these shims, this just looks like a round piece of plastic, and essentially that's what it is. But by cutting out certain notches, we're able to go through and make sure that our tires are pointed in the correct direction. We may have shims that allow us to change the angle of components. This literally is a wedge that we're going to use to hold 2 components apart and then bolt them together. And we may have to use special hardware. Now this may look like a regular bolt and nut, but you'll notice it has several washers, and then it has this black sliding piece, and I'm going to rotate this, and this outer section is off-center. This is what's known as an eccentric bolt. And by adjusting this eccentric, we're able to move certain components on the suspension system to get them into spec. Now, most shops will charge a flat rate for an alignment, and that's fine. However, just be aware that if your car is in serious need of repair, there may be additional costs associated with that, which you won't find out until the car is basically getting an alignment, and at that point you may have to go in a little deeper to replace components to get those parts into spec. Okay, so let me get this stuff out of the way, and I'll talk about some of the different angles that we have to deal with our alignment. So the first alignment angle is generally considered the most critical, and fortunately on most vehicles it's the one that's the easiest to adjust, and that angle is called toe. Now there's 2 types of basic toe angles for a vehicle. There's what's known as toe in, which is that the tops of the tires are pointed inwards toward the front. So it's almost like if you had your feet on the ground and you pointed your toes together. That's known as toe in. The other one is obviously toe out, which is that your toes are spread apart at the front. Now toe is going to cause 2 things. It's going to cause tires to wear very rapidly, extremely rapidly. I have seen cars that have had severe toe angle concerns, and literally you'll burn through a set of tires in maybe 6,000 miles. It's very, very rapid. The other thing that toe is going to cause is toe is going to cause the steering wheel of your car to be off center while you're going straight down the road. Toe won't cause the car to pull or drift, and it won't cause a vibration. And a lot of people think that, oh, my car vibrates on the highway, or I hear a noise when I do 65 miles an hour, I need an alignment. No, the only thing that alignments are going to prevent is a pull or a drift, and then also they're going to prevent tire wear. So if our toe was set for 0 as we went down the road, both tires would be pointed straight ahead, and my steering wheel would be dead level in the middle. If my toe, however, is not set to 0, if my wheels are toed in as I go down the road, what's going to happen is the outside edge of the tire is going to basically be plowing against the road surface as you drive straight down the road this way. That's going to cause excessive tire wear. It's going to cause tire wear on the outside of the edge of the tire, and that tire wear is going to be wiped across the entire face of the tire, across the entire surface as you're driving down the road. When you have two toe angles that are exactly the same like this, the steering wheel is actually going to be straight. However, most cars tend to have one wheel towed differently than the other. Now you might think that this would cause some type of pull as you went down the road, but the fact is what will happen is the two toe angles will sort of neutral each other out, and the car at that point is going to turn the steering wheel to the side, but the car will continue to go down the road straight. Now the reason why that happens is because on a vehicle you have to remember we have 4 tires. So we have a toe adjustment at the rear on most vehicles, and then we have a toe adjustment on the front at every vehicle just about ever made. So remember that toe is going to cause tire wear, and it's going to cause your steering wheel to be off center, but it won't actually cause the car to pull into another lane. Now if I do try to straighten the steering wheel out and the car changes direction, that's also toe at the same time. But the fact is that I could release my grip slightly on the wheel, not taking my hands all the way off, and I could kind of feel the car sort of neutral out a little bit, and the steering wheel would be crooked, but the car would go down the road straight. So that's the first angle, is toe. The second alignment angle that we're going to talk about is what's known as camber. And camber is looking at a tire from the front or rear of the vehicle and its tilt front to rear, whether it's pointed towards the outside of the car or tipped towards the inside of the car. Now camber typically is an angle that's built into most suspensions. You may have actually noticed if you were behind a European sports sedan that the rear wheels kind of look like they're tipped in at the tops and pushed out a little bit at the bottom. That is what's known as negative camber in the rear, and most manufacturers will install some negative camber in the rear of the vehicle because when you corner, what will happen is the side forces of the vehicle as it goes through the corner, that tire wants to almost stand up. It's going to give it more surface area to grab with, and it's really going to help the car handle. However, if we have too much excessive negative camber, it actually makes the car hard to steer, and we're going to get wear on the inside edges of the tires. Some manufacturers specify what's known as zero camber, and even still some manufacturers specify what's known as positive camber. If we have a little bit of positive camber, it's not a problem, but we want to make sure that we don't have excessive positive camber where we're going to wear the outside edges of the tires. Positive camber or zero camber makes a car steer very easily. Excessive negative camber on the front is going to make the car steer hard. The other thing that camber is going to cause is it's going to cause a pull. And I can use these little pieces as a demo to show you. So if I have equal camber, if I had negative camber and the car was going down the road, it would go down the road straight. However, if I have one wheel positive and one wheel negative, the car's going to want to roll in that direction. And what we say about camber is that it's always going to pull towards the more positive side. Now, if I have two negatives, whichever one's the least amount of negative, the car is going to pull in that direction. So when we do an alignment, we want to make sure that our camber reading is within specifications of whatever the manufacturer says, and that it's equal left to right. Typically, things that are going to cause camber to be out of specification would be a damaged lower control arm or something along those lines, where we might actually have to go in and replace some of the hardware to correct that angle. Okay, so that's camber. The next angle and the last angle that we have to talk about is what's known as caster. And caster is essentially, if you think about the front of a bicycle, the angle that we have going down to the front fork of the bicycle, if we drew a line, center line from the bottom of the tire up to where the handlebars are, there's a curve, and that is going to create a straight line in between the handlebars and the ground. That's what's known as positive caster. Positive caster is what we want to have with a suspension system. Positive caster or negative caster is viewed from the side of the car, and it's literally a line drawn from the top of the ball joint to the bottom of the ball joint all the way down to the ground. Generally, it's not going to be an angle as excessive here, but caster, interestingly enough, doesn't cause tire wear. What caster causes is a pull. So if I have my steering axis, and what I'm going to do is I'm going to stand these up, put these together. If I have these as basically what my struts or shocks would be, they'd be standing up in the straight zero position. That would be zero caster. Zero caster is going to make the vehicle very, can make it a little bit unstable. It's going to make it turn very easily. You can pivot very easily like that. However, we generally have a little bit of positive caster, which is towards the back of the car, pointed this way. And what that's going to do is that's going to make sure that when you are driving down the highway, you don't have to constantly fight the steering wheel to keep the car going straight ahead. Positive caster is also that seemingly magical force that when you are driving a car in a parking lot, you make a full lock left turn or right turn. When you go back, the wheel kind of magically goes back to the middle position. That happens because of our positive caster. The car wants to point straight ahead, and as long as my caster angles left and right are equal on the car, it's going to do that. However, over time, if I run into something and I crash this corner of the car, it's going to cause one side to go more negative towards the front of the car. And if I'm driving the car along and I point this more negative, what that's going to do is it's going to turn my axis and it's going to cause the car to turn to the other direction. What we say about caster is that caster is going to pull towards the more negative side of my angles, and oddly enough, caster doesn't cause tire wear, generally speaking. However, it's going to cause the car to pull. So if you have a car and you're driving along the highway and you're constantly fighting the wheel, you have to keep pressure on the wheel to keep the car going straight down the road. A lot of times it could be caster or it could be camber, but just remember that camber and toe are the only two that are going to cause tire wear. Okay, so now that we've looked at our different types of alignment angles, let me show you some of the ways that we mount our alignment angle sensors to our wheels to take our measurements. So the history of wheel alignments has basically been around for as long as we've had automobiles. It actually goes back even earlier than that. It goes back to carriages and horses, and making pretty much sure that all four wheels on a cart went down the road straight. So the earliest and easiest way to basically do a tire alignment is to just use a measuring tape. If you think of the four wheels having to be pointed straight ahead in a similar way that we create a foundation, or Mason would create a foundation for a building, you want that to be a level, equal rectangle. And essentially that's what we're doing. We're saying the four corners of the car, the four wheels of the car, are going to be what's used as my basis to make sure that they're all pointed in the same direction. But using nothing really more complicated than maybe some string or a measuring tape, I can get a pretty close, accurate measurement of, is the car pointed straight ahead? Is the car a square level box in relation to markings on a floor or markings on a wall that I can use as a reference point? So when we talk about a computerized alignment, which we'll get to in a minute here, essentially what we're using is we're using a computer to take those measurements rather than people just taking a measurement with a measuring tape. So after we went through and we started to do some measuring tape measurements, we came up with what's known as a magnetic caster camber gauge. Now this is essentially a three-angle carpenter's level. The back side of this is designed to mount to a steel hub of a wheel. And what we're able to do is by taking our measurements on here, we're able to take a look at bubbles, just like how a carpenter would use a level. And we're able to figure out the angles based on how this sits against a level surface and a floor. So this would normally sit here if I stand this tire up like so. This guy would sit here right in the middle of my wheel. and depending on the angle at which this tire was sitting, I would be able to figure out, are my angles equal left to right? So that also was an analog way to do our measurements. Later, when we went to computerized alignments, the angles at which we did this became much, much more critical. People started to realize that, wow, if the wheel is bent or the hub is bent, I don't want to take that bend into account when I do my wheel alignment. I have to be able to kind of rule that out from my measurements, which is impossible to do with analog types of measuring tools. So what we started to do with our computerized systems is we had an alignment head. Now this head bolts onto the wheel. I'm going to attach it just briefly here. And if you've ever seen a car get an alignment in a shop, you may have actually seen these types of heads sitting on the tire. This is a clamp that goes around the entire rim of the wheel, like so. And then we have this guy, and this is an infrared transmitter. Now what this does is it bolts onto the center of the hub here, like so, like that. This then communicates with 4 other sensors attached to the wheel, and at this point it's able to communicate back to a central computer, and it's able to detect very minute changes and adjustments in the wheel. This system is what we used for years. I'm going to go back and say we probably used this for, the basic idea of this, for maybe even up to 40 years. And with this system, it worked fairly well. The problem is it's heavy and complicated. These heads are very expensive. If they fall off the car while you're doing the alignment, they're pretty much damaged and ruined at that point. So these also had to be plugged in with cables. They were fairly complicated to work with. So as technology progressed, we moved away from that design to what we're going to use today. So we're going to use an optical aligner. This is my optical sensor. The way it works is there are cameras on the alignment rack that bounce off these reflectors, and this unit clamps on top of my wheel and tire assembly, like so. And then this points back to the cameras, at which point the computer is able to detect the slight changes in the alignment angles. This design is much better because it doesn't actually damage the surface of the wheel, it doesn't clamp anything to the wheel. This is soft plastic, and it just grabs onto the tire. It takes much less time to work with, and it's really shortened the amount of time a technician has to take to just set a car up to do an alignment. So now that we've looked at this, let's take a look at the actual alignment process. So I'm now obviously inside the vehicle, and we're sitting on the alignment rack. What I've done is I've hooked up 4 of those optical heads to the wheels. Now right now the computer is waiting for me to steer the car as directed. I'm going to turn the wheel to the left. What this is going to do is this is going to allow the computer to take a look at that angle called caster at the front wheels. Now you have to do that as a live measurement. Basically we have to actually show the car the angles as we were as we would turn the wheels if we were driving. So I'm going to go ahead, and I have this tool down by my foot called a brake pedal depressor that's going to hold the wheels still. I have to keep the car from moving right now to capture and record these angles accurately by the computer. So I'm going to turn the wheel to the right and wait till we get green, and now I'm going to point the car straight ahead, and it's really sensitive at this point because the alignment is out on this car. And right now I'm going to hop out of the car and we're going to take a look at what our angles are actually showing us. So now we're out of the car, and now that we've gone through the vehicle compensation procedure and setting up our caster angles, we can see an overall view of all of our alignment angles. Now, one thing this computer does is it greatly exaggerates the angles. And it does this for a couple reasons. One is so you can really visualize kind of how a wheel is sitting as the car is going down the road. So what we're looking at here with this photo on the screen is these are the tailpipes of the car. This would be the rear of the car towards us. This is the front of the car over here in the distance. So we're going to look at the rear first. Now what's neat about this computer setup is that I can click on a wheel. So looking at the rear passenger side corner of the vehicle, we can see that our camber is tipped too far in positive, and my toe is steering this back wheel towards the center of the car. That guy should be right in the middle of the green, and this guy should be right in the middle of the green. If we come over and look at the opposite side of the car, we can see that pretty much almost the exact opposite thing is occurring. So the back wheels of this vehicle, in terms of how the car is steered down the road, is it's trying to steer the car off center, and that's the thrust angle. And one of the rules of doing a four-wheel alignment is that you have to do the rear wheels first, because the rear wheels of the car are going to basically dictate the overall direction or the thrust angle of how that car is going down the road. Now, after I go through and do these rear adjustments, this thrust angle should straighten out. It should be almost exactly dead zero. But right now we can see that my camber is too far positive and my toe is pointed far too much to the left. And that's steering the car more towards the left. If we take a look at the front of the vehicle, looking at it from the top down, I'm able to see that my caster and camber numbers are really pretty good. Now, they're not exactly the same left to right, and that's okay. What I'm really concerned about is that they are in fact in the green. Now the camber on this is a little off center, and part of that is because one of the other things that you're supposed to do when you align a car is you're supposed to align it with a certain amount of weight in the car. Now this car unfortunately does not have a full tank of fuel, and the manufacturer of this car recommends that when you align it you do have a full tank of fuel. That would actually change some of these camber numbers slightly in the front. If I had a little more weight in the back of the car, that would actually even itself out. My caster numbers are good, and that's important because both my caster and camber on this car for the front actually require parts to be changed if they're not correctly dead center. Now the difference here of just 1/10 of a degree, while it may look like a lot on here, it's really, again, it's okay. The machine kind of over-exaggerates, and anything greater than a 1/2 of a degree change is really going to cause a pull or tire wear issue. I'm well within 1/2 a degree for both my camber difference and my caster difference as well. So my camber and caster in the front are pretty good, and I can see that my little arrow tops here are lined up. If I come over here and look at the vehicle from the top, I can see that my caster angle, it's a little far forward in the front, but it's still within the acceptable limits. My camber over here on this side is within my acceptable limits. It's also a little bit negative. However, my toe in the front is what is really out of whack on both sides. So this explains why my steering wheel is off center right now in the car, and also this would cause serious tire wear. So this car, the way it's set up right now, is the front is not going to cause a pull, but it is going to wear tires and my steering wheel is going to be off center. My back of the car, the rear of the car, my camber being off center this way is going to cause the car to drift and have a pull and wear tires. So it's a good thing that we have this car up on the alignment rack. If we sent this car out with 4 brand new tires, this car would not go down the road straight, and these tires would probably be burned off the car within 10,000 miles. And if you're buying tires for a car, tires can cost upwards of $1,000 for 4 new tires. You certainly want to spend a little bit of money to do an alignment to save those tires before you drive out of the shop. So what we're going to do is we're going to align the back of the car first, since that dictates the thrust angle of our car, and we'll take a look at what's involved at doing those alignment angles in the rear in getting these corrected. So I am here under the driver's side rear suspension of our Ford Fusion, and I'm going to do my adjustments underneath here. Now, what I have with the small box is this is called a pendant, and it allows me to control the computer at the front. It also gives me a digital readout of telling me what my angles should be and where they are right now. Without this, I'd have to kind of look through everything, and I can barely see the front, but you can see it much better than I can. So in order to do our rear adjustments, the first rear adjustment that we always have to make is what's known as camber, if it is adjustable. And on this car, it is adjustable. And it's this bolt right here. You'll notice that this bolt seems like it's off center a little bit, and that's because this is an eccentric bolt. What I'm able to do is I'm able to grab the head of the bolt on the opposite side of the tool, and with this loose, I should be able to turn the head of this bolt, and in the process actually change the camber angle of the rear of the vehicle. Now what that bolt is going to do is that's going to shift this lower control arm fore and aft. If you can imagine what that's going to do is that's going to push the top of the tire back and forth right now. So I'm going to push the camber button, and I see that I'm about 0.4 of a degree to positive. So right now the tire is like this. I have to push this down so the top of the tire is pointed inward towards the vehicle. And what I'm going to do is I'm going to loosen this, and then as I turn this adjustment, I should see this walk back into the green or center area. Now, if it starts walking in the opposite direction, that's okay. It just means I know that I'm going in the wrong direction in terms of what I'm turning underneath the car. So let me get this started, and we'll get this side adjusted. So get this guy loose and break that free. And one of the things that can happen is if your car has a lot of mileage on it, a lot of salt, rust, or corrosion underneath it as well, what is going to happen is these bolts can literally become seized. If you try to do an alignment on a vehicle that has not had an alignment done ever, and the car has 100 or more than 100,000 miles on it, these bolts might actually have to be replaced. If this car was damaged, if this lower control arm was bent because at some point somebody hit a curb or they were in a car accident, this entire piece would have to be replaced as well as having an alignment performed. So it's not always just turning some bolts to make everything right. We're lucky this car has never been hit, it just needs an alignment. So if I come in here and I turn my eccentric, I can turn it that way, and you can see that as I do that, my numbers start to move more towards the green area. And let me try going the opposite way here, see if that's a little bit easier to do. See if I can push that outward. And there we go, it's moving back a little more. And right about there, I'm gonna lock that, and I'm gonna hold that. That's pretty good. See if I can bump it a little more. No, that's the best it's gonna get. So that's pretty close. I'm definitely in the green at this point. So I'm gonna lock this side down. And again, this car doesn't have enough fuel in it, so that would change my reading a little bit. But there we go. And that's pretty good, right about there. I'm satisfied with that for that amount of movement. So what I'm going to do now is I'm going to do the adjustment on the other side, and then we'll come back and we'll change and fix our toe. So I'm going to push the camber button on this side, and I'm going to turn myself around and do the adjustment on the other side, and you can watch the screen while I do the adjustment. Okay, so I'm going to loosen this bolt first. And get this loose, and then I should be able to get my camber set back. Nope, that's going the wrong way, so I want to turn the bolt the opposite direction. And I should be able to get my camber to stand back up. And you notice that my thrust angle is starting to change a little bit. And that's because thrust angle is actually changed by the camber measurement. And that's why we do our camber adjustment first before we go back and adjust our toe. You notice that our toe adjustment has changed. And now that my camber is back into spec, and it's really close, it's almost dead even on both sides, I'm able to adjust my toe. So my toe adjustment is a link right here. And what toe is going to do is that's going to straighten the tire in and out this way. So right now, both tires, if you look at the monitor, they're both pointed in. The toe in is extreme on this vehicle. So I'm going to adjust my toe and then straighten my tires out. And once I have that done, we'll be done doing the adjustment here at the back of the car, and we can move at the front. Now, if I just left this the way it is, the car would go down the road relatively straight. However, it would really eat up these rear tires, so we don't want to have that happen. So let's do our adjustment. All right, so I'm going to loosen these two. There's a set of lock nuts right here to loosen them. And see if I can get this guy to loosen up a little bit. There we go. And now when I adjust this side, I'm going to push my toe button, and I should be able to see a change in my toe reading. Try to dictate which way I'm going to go. See if I'm going in the right direction or not. It looks like I'm going in the right direction. So I'm getting this closer, and I want to get this set up so it is in the middle. And it looks like they want me to get this dead on in the middle. And I'm getting really close. Oh, went a little far that way. Let me back this up just a hair. And right about there. Pretty close. It's really sensitive when you're setting toe. So I'm going to lock that side down. And I'll have to come back and remember to tighten those down. And now I'm going to adjust the toe on the opposite side of the car. Let's see, which way am I going? I'm going the wrong way. So make this tighter. And I'm moving this in, and as it's moving in, should be straightening it out a little bit. And roll this back. And I'll lock this down. And again, I'm not going to fully tighten these down. I may actually have to go back, since this car was so out of adjustment in the rear, I may actually have to go back and recheck my camber measurements to make sure that they haven't shifted. And they have shifted a little bit, so now I actually have to loosen them and adjust them slightly. So there's a lot of give and take when you do an alignment. And you have to be really patient. And sometimes it can take a technician a long time to do this, especially if the underside of the car is excessively corroded or rusty or muddy like I was talking about. So let me come back and we'll adjust this side, and then we should be able to finish everything up. Let's see here. go. That's straightening out. All right, and we'll come back and we'll do this side. And a lot of times when you're doing an alignment, it is just a lot of give and take, and you have to be patient to make sure you're adjusting things correctly. Okay, so again, if you notice now my toe is out again, and this is pretty normal. So the reason why I didn't lock these down super tight was because I'd have to go back and loosen them again. So we'll adjust this side, and then we should be good to go. And so I'll get this side adjusted first. Make sure I'm going in the right direction. There we go. Back it off a little bit. Now I'll adjust this side. All right, so now that both my left and right camber and toe are adjusted, I'm just going to check them right back here on the pendant. My camber came out a little bit on this side, so one last final adjustment and we should be good. I still may have to go back and adjust toe. Bring this in a little bit, right to about there. Then I'll go back and recheck my toe. Yep, and then I got to adjust the toe one last time on this side. And again, this is common. This is why it takes time and why people get paid. It's sort of like a game in the sense that the car is set up to the computer like a video game controller, and you have to do just very fine adjustments like a surgeon, and one adjustment causes other parts to go out of adjustment. But I think we just about got it. We are all in the green in the back, so at this point I'm going to go up front and I'm going to adjust the front end of this car. See you there. Okay, so now we're under the front of the car and we're going to adjust our front toe. Now, I don't have to worry about my caster and camber measurements because they are already in the green. And the fact is that when we put a little bit of weight in the car again from the fuel tank, they'll probably level out, so I'm not worried about them. But if you look at the screen, the angles that are in severe need of adjustment is my front toe. And the nice thing is that front toe on all vehicles is the one adjustment that is always adjustable. Now, if you have a front toe adjustment, remember the problems you're going to see is that you're going to have extreme tire wear and the steering wheel would be off center, but the car would actually go down the road straight. Now, it might be hard to visualize the car going down the road straight right now with both wheels pointed towards the right side of the car. But the fact is those wheels would actually kind of plow to a neutral center position, and in the process they would turn the wheel severely off center. So what I'm going to do is I'm going to start by adjusting the passenger side wheel first, and I'm going to set this up so we can see bar graphs, and I can see it here on the pendant as well on the screen. And what we're going to do is I'm going to adjust my toe first and set this up. And then we are going to get this set up. I'm going to adjust the passenger side one first. Now, when I do the toe adjustment, typically there's a lock nut right here that's up against this outer tie rod end. The way that most vehicles have their toe adjusted is we loosen this lock nut and then we turn this inner sleeve piece right here where I'm pointing. And at that, what that's going to do is that's going to steer my tie rod in or out, and in the process adjust my front toe angle depending on how it's pointed underneath the vehicle.
Keep going. We'll cut that out.
Okay.
Who was that?
Just a student, like, walking by. That's okay. All right. So I'm going to take my wrench, I'm going to loosen my lock nut, and again, if this has been severely corroded, they normally don't spin this easily. If this has been really corroded, you're normally turning this quite a bit to make this adjustment. And again, I'm going to turn my tie rod a little bit to see if I'm going in the right direction or the wrong direction. And it looks like I need to adjust this a little bit this way. And I'm getting this straightened out. Now, the other thing I've done is up in the vehicle, I've straightened the steering wheel and I've installed what's known as a steering wheel holder. So my steering wheel inside the car right now is level. So once I get this straight, all my angles are good, which they should be because I've been adjusting them. I should be able to get this car to go down the road straight without any meaningful tire wear. So there goes my toe. And I'm adjusting getting that just there on the center. And I'm going to lock this guy down temporarily. And now I'm going to adjust my other side. Loosen my lock nut. There we go. And get this adjusted as well. That's coming into straight ahead position. Slow down a little bit, and I can get that just about perfect right there. Is close enough. Now that everything's green, front to back, what we're going to do is I'm going to hop out from here. And we're going to take a look at our measurements overall and see how they'd affect the car going down the road, which they really shouldn't affect it now at this point. I got all my measurements back in the green. I got all my adjustments made. I'll just have to lock everything down, and then we can take a look at our adjustments. So we're all done our alignment at this point. We've aligned the rear of the car. We've aligned the front of the car. And what I have on the screen right now is an overall view of all of my adjustments. Now, taking a look at this, everything's in the green. The only thing that might be a slight concern is my camber in the front. It's a little high in terms of a difference. I'm at that 1/2 degree difference. However, The left side is the driver's side of the car. When I get into the driver's side of the car, that side of the car is going to level, and it's going to pull this a little more negative. Also going back to the fact that this car doesn't have a full tank of fuel when we did the adjustment, that could be another thing to come into play. But my rear is good. My thrust angle is 0, which means this car is going to go down the road dead straight. My rear toe is good. My rear camber is good. And if I come over and I look at my virtual view, we can see that all 4 of our wheels are now in the green. And the car, again, my thrust angle, is dead 0. So at this point, when you're done in alignment, it's important to get a proof that the work was performed. You'd never want to just take somebody's word that they did an alignment. You'd need to see the before and the after. So what we're going to do is we can print out our alignment specs. And we'll pull this out here. Pull out our tray. And our steering wheel is pointed straight ahead. And what this is going to be able to show me is that this was my before picture, and then down here, this is my after picture. And I can make a note at this point. I could say, oh yeah, by the way, I found an oil leak underneath your car. You have an exhaust leak or something like that you might want to get taken care of. But you always want to make sure that you get a printout when you're done, so that way you have proof. It's a record. It would go into the customer's file that you had work done. And you also want to see that work was actually done, that you got something for your money, and that the car is going to be going down the road straight and correct. So we'll wait for our printout to come out here. And there we go. So I have my before and my after, and this would go into the customer's file. It has the VIN number, the date and the time, and that's my proof that I got my alignment done. The car's going to go down the road straight and not eat tires. I'm Dan Reed. Thanks for watching Car Corner. Drive safely.
You do it so well.
I want to do the slate. Love that slate. I went to school for slating. And then when I click ready, it should come up and give us an accurate picture of what our alignment angles look like on the vehicle. So here we go. And everything is grayed out, which is not what it's supposed to do. Yay TV. Good audible slate. Good to go? Okay, so now I am just hitting my head. There's an exhaust pipe there. Good thing it's not. Let me move the seat a little bit. There we go. Let's try that again.
As soon as you clicked on what you just did to zoom in, that's when it went.
Well, we'll just have to
Well, that's a cool sound effect.
just live with it.
Pew!
Live with it.
Pew!
Already